Let us do question 20, which is radioactivity. So a radioactive material gives a count rate of 8,000 count per minute. After 20 days, it gives a count rate of 500 count per minute. What is the half-life? So the initial count rate was 8,000, then the final count rate was 500, then the time which has been given is 20 days. Then we are looking for half-life. So we can answer this question in this simple way. So let's get the data. So the data which you have is that the initial count was 8,000 count per minute. Then the final count was 500 count per minute. Then time allocated was 20 days. You're looking for half-life, which you don't know. So how can we answer this one without using logarithm? So we'll say number, or the simple formula is this: 1 over 2 to the power n is equal to number of counts, which is initial, then final, then number of count, which is initial. So after this formula now, then you can say half-life given is equal to time over number of disintegration. How many times it disintegrated for us to get the half-life. Therefore, we'll say 1 over 2 to the power n, which is equivalent to 500, which is the final, over 8 8,000. So 1 over 2 to the power n is equal to you cancel. So 5 into 5, it's 1. Then 5 into 80, it will give us 16. So what we have now here, we're looking for this value of n. So we can cross multiply. So 2 to the power n times 1, we're going to get 2 to the power n. Then 1 times 16, we're going to get 16. From here, we're going to use the law of indices, where we need to make the bases to become equal. Therefore, we'll say 2 to the power n is equal to 2. Then how many times can you multiply 2 to get 16? It is 4. So the bases are equal. We can cancel them. So n is equal to 4. To find half-life, we'll proceed by saying half-life is equal to time given over number of disintegration. So the time given is 20. So 20 over 4, which is equal to what? 5. Which is equal to 5. So we have 5 days as our final answer. So this is how we do simple half-life calculation when the number of counts are given.